All right, so we're going to take a look at describing transformations of functions. This is a little similar to the one before. The difference being is they give you the function and tell you to apply the rules to it, and they ask you what is the function that results, as opposed to what we did before is they give you two functions and ask you what the rule is. So very similar, and we're going to use a mix of the calculator and doing it by hand on this, just so I can give you more calculator practice. But on the easy ones, we're just going to do the rules. So what it's saying is start off here and reflect it over the x-axis. What will that look like? Okay, so think about what a reflection over the x-axis means. You would think it's inside because it's x, but remember reflections are opposite, right? It's negatives and the opposite. So it's really on the outside. So what that means is the numbers on the outside are going to change by negative, right? So if it's a positive 10, you should expect a negative 10. If it's a negative 4, you should expect a positive 4. So this one, okay? So again, if you understand the rule, you don't actually have to put it in the calculator, but if you are kind of struggling with it, you can put it in the calculator. So I'll do a mix just to make sure. All right, so this is a reflection over the x-axis. So again, reflections are negatives and they're opposite no matter where you, whatever you think. So you'd think this is going to be on the inside because it's x, but reflections are opposite. So it's really negatives on the outside only. So I should expect this to change and this to change on the outside. So I should have negative and a negative, negative and a negative. So this one right here. Okay, so again, let me go ahead and put one in a calculator just so I can make sure if you don't understand the rule, you at least have a calculator. Of course, I'd pick one that's complicated. We're going to do it by hand first and then check it with a calculator. So reflection over the y-axis. So reflections are changing the negatives, right? Y you think is outside, but it's opposite because reflections are opposite whether they're outside or inside. So instead of it being a negative changing on the y outside, so you change it on the inside. So the only thing that I would expect to change is this should be plus 6. Everything else stays the same. That. All right, now I'm going to check it with a calculator. Okay, so again, what you're going to do is you're going to copy and paste. And to kind of make this simple, I'm just going to check my answer. See, the calculator will be really long because you're going to have to put all 4 answers to see what happened. So I'm going to zoom out. Is this, oh wait, it didn't copy. Make sure it copies, exactly. I was like, where's my quadratic? Where's my happy or sad face? All right, so what happens to this black line? So I'm going to put in this second one. So the only thing I'm going to change is this to positive. And that should do what? Flip it over the y-axis. So it should come on this side somewhere. Okay, so let's see if we're right. So in fact, you can use it to check. How about that? All right, and we're going to change. Oh, let's just copy this one. It's the same thing, and the only difference is that we're changing this from negative to positive, right? So this one right here is going to change to positive, and I should expect it over here. Oh, that's not a positive. Positive. Boom. Did it flip over the y? It did. So then I know that I'm correct. So you can do this with a calculator. You can do it by hand. I find doing it by hand is a little bit faster, but the choice, of course, is up to you because you do have an option of both. All right, so reflection across the x-axis. Again, reflections are negatives. And x, you would think is just the inside changing, but it's going to be opposite of what you think. So I should expect this to change and that to change. So they should both be negative, both negative. All right, I'll do one more with a calculator, and after that, I'm not doing it because it's just too much for me to copy and paste. Because look at me, I'm still copy and paste. And then I need to change the negatives right here. So I need this to be a negative and this to be a negative. All right, I'm going to hide this so we can talk about it. So this is a reflection over the x-axis, which means you fold it over the x-axis. So this line right here, when you fold it over, it should come over here. And this line should come over here. So it should look like this. It should make like an X going through 0, 0. So let's see if it does that. Yes, it does. Yay. So we're right. All right. So again, you could use a calculator or you could go ahead and do it. So some questions I will, some I won't. All right. Let's see. 3 left and 2 down. So maybe on a question like this, it might be faster. So let me show you what I would do and then you guys decide what you want to do. All right. So you start off with this one and you want to move it 3 left and 2 down. All right, so what does that mean? 3 left and 2 down. So I start off with 3. Oops. Maybe this one might be faster with a calculator. 3x, right? And I want to move it 3 left. So what does that mean? Plus 3, because remember it's x and opposite. So opposite will be this way, right? 3 left, and then this one has a minus 6 already, and I want to move it 2 down. So minus 2, 2 down. All right, then you have to simplify it because it has to look like this. So let's go ahead and multiply this out. Yeah, it might be faster on the calculator on this one. So 3x, and then here you're going to have, what's that? 3 times 3 is 9. The negative 6 minus 2 is negative 8, so you have that. So now it's going to be 3x. What's 9 minus 8? Plus 1. So I'm looking for 3x plus 1, which is this one. And that might be faster with a calculator. Let's do a calculator and see whether we agree. Wrong one, calculator. Calculator. Here we go. All right, so let's see if we put it in the calculator, how much work we'd have to do. So let's take this. So if you were doing this with a calculator, of course, this is what I think the right answer is. You wouldn't know that, right? So you'd have to put all these answers in and see if it moved 3 left and 2 down. This we did at the end of the last video. I kind of showed you how to start at 1 point and count. So let's pick this one first, because we don't know what the answer is if you didn't know the rule, right? So this is minus 13. All right, so 3 left and 2 down. That's what we're looking to do. 3 left and 2 down. I'm going to zoom in a little bit, and I want to go from blue to purple by going 3 down. What was it again? 3 down and 3 left, sorry, and 2 down. 3 left and 2 down. So pick any point you want. So let's pick this point right here. Okay, so I went blue to purple. 3 left, 2 down. So if I go left 3, so take this point, 1, 2, 3, and then I go 2 down. Do I get the purple line? No. So purple is not the answer. And you literally have to do this with every single answer until you get this last one. So let's take 3x minus 17. And so, see, sometimes the calculator might not be faster. But again, your choice. All right, so do I go from blue to black by going 3 left and 2 down? So again, pick any point. I'm going to pick this one. 1, 2, 3, 1, 2. Did I get to the black line? I did not. So that's not the answer. So boom, try 3x plus 5. So I'm on C. I have to check every single one. Did I get the answer by going 3 left and 2 down? So I'm going from blue to red. All right, so again, start off with the point that you want. Just going up. We'll zoom in a little bit. So each box is a box. Okay, so 1, 2, 3, and 1, 2. Did I get to the red line? No. So it must be D, but again, you'd have to check every single one. So this is plus 1. So this should be the right answer. All right, so again, let me zoom in. Each box is 1. Did I go from this point? Did I go 1, 2, 3, 1, 2? Am I on the red line? I am. Okay, so that took equally as long, I think. I think this one was shorter than me plugging all of them in. But again, your choice, whatever it is that you want to do. All right, so I'm going to stick to the work. You can definitely go into the calculator and do it because I'm not doing that again. All right, so let's go ahead and do this question. All right, so I have this function here and I'm moving it 6 up. So I start off with a function 5x minus 9 and I move it 6 up. 6 up, right, is plus 6 on the y. So only on the outside I'm going to add 6. All right, so combining that, so I have negatives are meeting positives, they're going to fight. Negatives are going to win by how many? By 3. And so this is my answer choice. So again, it just depends on what you find easier. You can definitely put it in the calculator, but I think this might be faster, but your choice. All right, boom. Now we're getting a graph and we're being asked, all right, what is the transformation rule? Give me 1 second, let me erase this. All right, so the graph shows g of x, which is a translation of x squared, okay? Write the function rule for g of x. Okay, cool. So they're saying g of x is this, but we started with f of x, which was x squared. Now you have to turn right back to the very beginning when we talked about parent graphs. You have to know what that looks like. It starts off with a u like this, and if you don't know, again, you can just put it in the calculator, but I do know what it looks like. My original function, oh, I can't write on that. My original function looks like this, and you can just put x squared in the calculator and you'll see that it's like that, okay? So what did I do to it? I moved it 6 to the right and up 1 because it first starts right here. 6 to the right, up 1. And did I stretch or shrink it? No, because it usually goes 1, 1, and 1, 1. Okay, so how do I write this? So I take what they wrote. Let's see if I can copy and paste. Nope, I cannot. All right, so I'm just going to kind of type this in and then hopefully copy it down. So here I should have like an x. Okay, cool. So I'm going to copy this for the next question because hopefully I can just copy and paste. All right, so I took this function x squared, and what did I do? I moved right 6, up 1. So how do I write right 6? It should be inside, opposite of what you think. So right, you'd think positive, but so it's minus 6. And then up 1 is outside, plus 1. Okay, again, you can use it might be faster actually to use a calculator on this. Let's see. So I'm going to pull up a calculator real quick. All right, let's pull up this calculator. So it tells you start off with x squared. So x squared. And then it tells you, oh, but there are no answer choices on this. So you have to know what happened to it. So you have to get this function. So remember what I was telling you. It starts off at 0, 0. It goes, let's scroll. This is 1, 2, 3, 4, 5. Okay. Starts off at 0, 0. It goes 1, 1, right? So 1 squared is 1. 2 squared is 4. And as long as it keeps that pattern, so 1, 1, 2, 4, it didn't shrink. So 1, 1, 2, 1, 2, 3, 4. So it didn't stretch or shrink because you got to be careful with the graph ones. So all I moved, so I'm saying, I'm checking my answer. So how would I do this without a calculator, or rather by calculator, without knowing my rules? Give me a second to think. But right now I'm just going to check my answer, minus 6 plus 1. And I should go, see, right there. Let me make this bigger so you can see. So I go right 6 up 1. So let me just double check some random point like this one right here. 8, 5 is on the graph. All right, so 8, 1, 2, 3, 4, 5. So this is correct. Let me think real quick. How can I do this right from the calculator? Oh, I got it. I can put in a table of points and then have it write this fraction. So let's see, this is not going to be really long. All right, so let's put in a table of points, and we're going to get some points from the answer. So the answer is 6, 1. So 6, 1. And then we have 7, 2. 7, 2. 8, 5. And that should be enough. All right, now because it's a quadratic one, oh, but we have to have it in this vertex form. Oh, you see, now that becomes harder. Let's see, let me think. Yeah, because I can get to it in standard form, but in vertex form, you'd have to convert it. Let me think. Yeah, I'm not sure. I can get it for you real quick in standard, and then you guys can complete the square to convert it, but I don't know how to complete the square in the calculator. So what I'm talking about is we could write y, so we've done this before, y squiggly line, y1 actually, y1 squiggly line, there's my squiggly line, and then it goes ax squared, so this is just the standard form for it, right, plus bx plus c. And all the word parts where you have x's, those need to be ones according to my table. Yep. And so these are my answers right here. So I have this, but in place of, I'm going to put my equal sign now. And I'm going to show you it's going to be this graph we're looking for. Oops. I'm just going to delete the sub ones. All right, perfect. And we're going to change A is 1, B is negative 12, and C is 37. And you're going to see that this graph is going to be the graph I'm looking for, you see. So green, so I'm going to delete everything else so you don't get confused. Green is going to be my blue graph, see that? But this is in standard form, and you have to get it to this. So we can still do it, but again, this is a really long version. So getting this to vertex form, remember you divide by 2. So let me write it out here. And even let me put an equal sign. Divide this by 2, so that's going to be negative 6 right here, right? Square it would be 36. Multiply and apply to the other side, so it'll be 36 on the other side because there's nothing here. And then this 37, you have to take it to the other side, so it'll be negative 37 on this side. Combine these two, which is negative 1. So now I have negative 1 on this side. And then take it back because there was no equal sign. That would change it from negative back to positive. And you see you end up at the same place. But that's way too much work. So for this question, I think knowing the rules is what's going to help you. Okay, so I think you just have to know the rules to see, and then you can check it before you press enter. That's the best way I can tell you. All right, so again, let's set this up. So boom, there's going to be an x. What happened to it? So my original function, let's make sure it goes 1, 1, and then 2, 1, 2, 3, 4, because it's an x squared. So nothing happened stretched. It just moved. It moved from 0 down here. So how did that move? 1, 2, 3, 4 to the left and down 10. 4 to the left. Remember, it's x and opposite, so left would be plus 4, and then down 10, remember it's y and regular, so minus 10 on the outside. And of course, you can plug this in here to just make sure it looks like this before you press submit. Okay, I'm not going to do that each time. All right, what happened here? So again, just double check your function. It goes 1 1, and then it goes 2 4. So no stretches, no shrinks. All it did is move. What did it do? It moved to the right 2. And how do I write that? Inside minus 2. So again, if you know your rules, this becomes very quick. But if you don't, you can definitely use the calculator. So right 2 should be minus 2. You can use your calculator, and that's just going to be a really long work. All right, this is an absolute function, so you got to know what the regular one looks like. So here's the regular one. Go ahead and put it in the calculator if you don't know. But all it means is for every x value, you're only taking the positive y value. Maybe you have to write y equals, let's see. Maybe it doesn't like the absolute value, so go ahead and type it in. Find absolute on your calculator. Where is that? Oh, wait, I think I just passed it there. X. Yeah, I just didn't like the IX cells. So you can see, and I'm going to zoom in so that it's going up 1, 2, 3. Yeah, it's going up by 1. All right, what absolute value means is for every x value, just take the positive. So when x is 1, it's positive 1. When x is negative 1, it's still positive 1. Just take the positive. So it's always 1, 1, then 2, 2, 3, 3, 4, 4 in both directions. That's really the pattern you need to understand to write it. So you start off with writing your answer, right? Which is going to be, boom, absolute value. This is what I need. What happened to it? So let's check. Is it 1, 1? Yep. 2, 2 in both directions. 1, 1, 2, 2. Yep. So it did not shrink or stretch. All it did is move. So what did it move from? It started at 0, right? It was a 0, absolute value of 0, 0. All right, it started at 0 and it moved left 5 and down 9. How do I write that? Left 5 plus 5 and down 9, outside, down 9. Okay, so left 5, down 9. Yeah, so it's really much faster to do this by hand than not calculator. All right, so what happened to it? So this is what it looks like. It looks like a V, and now it's flipped over the what? The x-axis. So remember, flipping is opposite no matter what it is. So if you flip over x, you think it's inside, but it's really outside that has changed. So you start off with your regular function, which is absolute value, and then change the outsides to negative. And again, you can just double check that with a calculator to make sure that you're good. Watch me put this negative, it's going to flip right over. See that? All right, but just make sure it's 1, 1, 2, 2, 3, 3. It didn't shrink, because if it shrunk or did anything else, I'd have to put another number in here. All right, so you can check your answer with a calculator to make sure it did what it did. All right, so again, here's another problem. We're going to transform this unit, and you have no answer choices. So you do have to actually learn how to do this by hand. All right, so no answer choices means I have to work it out. All right, so let's work it out. You start off with your function. So I have 2x plus 6. And this part you can put in the calculator. Move it 11 down and see what the new line is, I guess. All right, so 11 units down. So that's 11 down is outside. It's y and regular, so you're just going to do outside minus 11, nothing inside. So go ahead and combine this. Positives are meeting negatives. They're going to fight. Negatives win by 5. So this is going to be 2x minus 5. And again, you can just double check that 2x minus 5. So now I have two answers. I can check. Did this move 11 down? That's what I'm looking for. So going back to the calculator, I'm double checking. So I already have an answer, but I'm just double checking it. All right, so I start off with this, and then I move it 11 down to get this. So let's see if that worked. So red to blue. All right, hit home to see all of it. All right, pick a point. This is a nice point, right? 0, 6, yep. And we're just going to move this point 11 down. So if it's 6, 6 to 0, plus another 5, that worked. So I just double checked to make sure I was right. I think that's the best thing you can do with a calculator. This one, you do have to know the rules. All right, 3 units right. All right, so right is only about the inside, right? So you're going to start off with your, you're going to start off with your equation. And this time you are having an absolute value, but you see, it doesn't matter what function it is. The rules are the same. I'm going to leave a space on the inside because I know right is inside, is x and inside. All right, and what am I doing? Right is opposite, so it's going to be minus 3. All right, so go ahead and combine that. So it's going to be negative 9. X, positives are meeting negatives. Just put that in the calculator. It's going to be positives win by 3. I don't know what's going on with my writing. And everything else stays the same. So come right here. This is x in the inside. Outside we have -9. Everything stayed the same. And the inside is now going to be +3. And then outside -1. So again, you can check that right in the calculator. All right, so let's check this. And remember, it doesn't like the IXL's absolute value, so you're going to have to type it in. So let's type it in absolute value, close of x plus 6. So I'm typing in this original equation, -1. And then my answer choice that I think it is. So remember, this needs to move to the right only 3. And I now think this is going to be +3. I'm going to hide the blue one, make it full screen so you can see. Kind of scroll in a little bit. All right, does the blue one move right 3? It does. 1, 2, 3. And it still goes, let me zoom in. Yeah, it still has the same shape, like it hasn't gotten thinner or fatter. It's exactly the same on both. All it did is move right 3. All right, so you can definitely use a calculator to check it, but you are going to have to know your transformation rules. All right, so 4 left. So again, I'm just going to check it right in the calculator as I do it. 4 left. So this needs to be squared. All right, we're going to, oops, undo. All right, so I just need to move 4 left. So I just did the same equation twice. 4 left would mean, so zoom out so you can see. All right, so I need the green one. There's the green one, right? All right, I need this to move 4 left. I'm going to say 4 left is minus, opposite is plus, so +4. Did it move 4 left? 1, 2, 3, 4. Ooh, wait a minute now. Oh, because I put 5. How about that? 4. All right, did it move 4 left? 1, 2, 3, 4. It did. But you can't put this as an answer. You have to simplify this. So actually, you can use the calculator to check your work the whole time. -8 plus 4. So negatives win by 4. So I just need to do that. Is that in the same position? 1, 2, 3, 4. It is. So this is my correct answer. So actually, instead of doing the work on paper, oh man, it doesn't like that. Okay, so it doesn't copy. Let me try it again. Yeah, it doesn't copy. Okay, cool. So it should be 3x minus 4 minus 9. 3x minus 4. Make sure you're typing it correctly. -4 minus 9. All right, so instead of doing the work on paper, you can do the work in the calculator and just make sure the graph does not move. That way, that's the best thing I can come up with the calculator. So again, we're going to copy this into the calculator, and IXL, for whatever reason, does not like the Desmos calculator, the copy and paste. So we're going to have to write it in. Let's see what it can copy. Let's see what it copies. So Control-C to copy, Control-V. Oh, it kind of did. Oh, but it doesn't like this. So delete the absolute, put Desmos absolute, because it doesn't like that. Yeah, there you go. So that's my original one. So we're going to copy the original one twice. This is just me doing the work. We're going to move it 7 to the right. So as we're doing it, you're going to see if this graph moves 7 to the right. So 7 to the right is about here. So whatever you're doing, 7 to the right. So you think it's +7, but it's opposite, so it's -7. Did it move 7? 1, 2, 3, 4, 5, 6. So I'm good. I changed the right thing. So I'm just doing the math inside the calculator now. All right, 6 units up. All right, did I move 6 units up? So up is outside, Y is regular. So now I'm right here. I'm going to move 1, 2, 3, 4, 5, 6. So I'm going to be over here somewhere. All right, so I'm going to say +6 to move it up, and boom, I'm right there. But you cannot put this in the answer because it's not simplified. So if you don't trust your work, you can copy it and paste it, and it's going to give you an answer. And what you want to do is when you change this answer, I'm going to change this to a -8. Make sure this graph does not move. See, it didn't move. So I know that my calculation's right. I'm going to put this on the outside here for it to simplify it, or you can do it in your head, 8. So I'm going to change that to 8. And again, watch here. That should not move. If it did not move, I know I simplified it right. If it moves, I know I've made a mistake in my simplification. So that's how you can use your calculator. All right, let's see what it'll let me paste. None of that. Okay, so cool. All right, so you got to type it out. This is 8, then x minus 8. And just be careful to make sure you type in exactly what you had. All right. And of course, as I said that, what did I type in wrong? All right, 7 right and 6 up. That's what I did, right? All right, so let's find my mistake, because sometimes you make them. Did I copy the question wrong? I did. Look, guys, the question was -8, right? What did I type in? Just +8. So yeah, definitely, because watch. Even if I put negative, it's still gonna do right. What was it doing? Right 7, up 6. So I'm gonna change the answers to these negatives. All it's gonna do is flip it. And you're still gonna move right 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So please be sure when you're copying and pasting that you're copying and pasting the right question over. All right, so reflection over the y-axis, negatives are changing. Y, you think outside, but it's really opposite, so inside. So just this one. So it's just the x one that's changing, so I would just do negative. So some of these are quick, some of them you're going to have to, like, do some work. All right, 3 units down. So again, 3 units down is just this. So -3, that would be -4. So exact same thing, -4. Since it doesn't like me copying and pasting, I hate that. We're going to have to type it up, and just be careful. Don't make the mistake that I'm making. And then this -1, 3 down will be -4. Okay, so again, knowing the, right, so it looks like they mix up giving you a graph or giving you numbers. So again, you need to write it in this form. I'm going to go ahead and get that ready so that I'm ready to go. So X right there. So again, it looks like a V, right? And it goes 1, 1, 2, 2, and so forth. So this is a downward V, so it's flipped, and it goes 1, 1, 2, 2. So it didn't stretch or shrink. But I'm going to do a few things to this. I'm going to flip it over the x-axis. What I mean by that is I'm just going to show you. So I'm going to start with the original, right? Here's the original. I'm going to make it upside down by flipping it over the x-axis. Where do I put that negative, inside or outside? All right, so usually if I flip over the x, you'd think it's inside, but negatives are opposite no matter what, so I put it outside. So flipped over the x-axis. All right, so negative. And that's not it, because that's not what it looks like. I now have to move this right 5 and up 2. So how do I write that out? So right 5. So watch this move. It should move right 5 spaces. So it starts at 0, 0, right 5 opposite. So it's going to be -5. See? Right 5 and then up 2. And then I should put a +2 to move it up 2. Boom. All right, so you can put the original one back just to make sure that it did what it's supposed to do. That's the original. Well, actually, it didn't look like that. No, actually, it did. So sorry. This is the original one, right? And it ends up over here by doing these transformations. So you just need to make sure that this is at 3, 0. Yep, 3, 0. This point right here is at 7, 0. 7, 0 right there. So this is correct. So I can type that in. So this is -5 and +2. All right, so you can definitely use the calculator to check to make sure you're okay. Again, this is also still an absolute value. So again, start off with what you have. All right, what did I do to it? It still looks like a V. Now, careful, all right, because watch, it doesn't go 1, 1, right? So this means it has vertically stretched because it's flatter, right? It's vertically, not vertically, what way is this? Horizontal. Horizontally stretched like this. So it goes from 1, 1 to 1, 2, 3, 1. So that makes a difference. So first, let me move it, right? So it goes 1, 2, 3, 1. And we're going to do that over here as well, just to make sure. So I need to move it up here to where it's at -7 and +9. So I need to move it 7 left, so that's going to be +7, and up 9, +9. So at that point, I should have moved where that is. And I'm just going to zoom in so you can see. All right, let me put the original one back. Well, actually, it's fine. Doesn't matter. So I'm at -7 and +9. So far, I'm good. And I have to now stretch it. So this is one more step. Okay, so now that I have it in the right spot at -7 and 9, okay, all I have to do now is change it from going 1, 1, rise over run, 1, 1, to going 1, 1, 2, 3. So let's see, if I add 1 divided by 3, you see how it's stretched out horizontally, right? 1, 1, 2, 3. 1, 1, 2, 3. So this point should be at -4, 10. So this point right here should be at -4, 10. All right, and you can see that it is. Okay, -4, 10. Perfect. So put that in the answer, and you should be good. All right, so be careful to check to see if there are stretches and shrinks. I guess when you get higher up, they start becoming 1. All right, so again, absolute value. So again, start with the absolute value. All right, I'm going to flip it. So I'm just going to show you with the calculator so you can see that that's what's happening. I'm going to flip it over the x-axis. And so where do I put that negative? Inside or outside? So let me write my answer as well here. All right. Flipping it over the x-axis, you would think it's inside, but negatives are opposite no matter what, so it's outside. So see, flips over the x. That's fine. It doesn't move, but let's check slope. See how it goes 1, 1, right? Or we can do rise and run, 1, 1. This one goes 1, 2, 3, 4, 1. Okay, so that's different, right? So that one goes 4, 1. So we're going to put it on the other one. And let's see if that worked. So 1, 2, 3, 4, 1. I'm going to just check the other point. 1, 2, 3, 4, 1. All right, so 1, 2, 3, 4, 1. And that's perfect. So that works. So that's your function. All right, so that's how you can use the calculator just to double check your work as you're going. So again, we have an absolute value function. All right, let's start off with, we need to flip it, okay? We need to flip it over the x, so that's opposite, so it's going to be outside. It's flipped over x right now. So we're going to go ahead and write that in. All right, now we need to check the slope. So is it still 1, 1? Yes, it is. 1, 1, and it should be 2, 2. Yep. So nothing happens to the slope. We just need to move it to the right 9. Right 9 should be minus 9. All right, right 9 is minus 9. And is that where it's supposed to be? Should it be at 9, 0? It is. Let me pick another random point like this one right here. Negative 9, 0. Is this negative 9, 0? Oh, sorry, 0, negative 9. Yes, it is. So this is correct. So we're just going to type that in. All right, so just understanding your transformations makes this a lot faster, but you can definitely use the calculator to check. Again, we start with the absolute value. What do we do to it? We need to flip it on the outside. Boom. So we're going to go ahead and do that here in my answer choice. Okay, we flipped it. All right, still doesn't look like this. All right, so let's talk about where this point is. We've moved the point left 1, up 8. So how do I say left 1? Left is plus 1, right? Because it's inside, it's opposite. And then up 8 should be y and regular, so plus 8. All right, so just check it. Is that point at negative 1, 8? Yes, it is. All right, cool. Now, let's check the slope. So the slope should be 2, 1, right? And right now it's 1, 1. So I need to make it 2, 1. So we're just going to put 2 over 1, which simplifies to 2. 2, 1. Exactly. Now let's check a random point. Let's check this one right here. Do you have a point? That's 3, 0 right here. I do. So this is your final answer. Just type it out. Okay, so this is how you can use the calculator to check it, but we know the transformations. That's how we're checking our answer. All right, so again, absolute value. So whether it's quadratic, absolute value, the rules are the same. You start off with the regular, flip it. So I need a negative outside. Let me put this on my answer choice. All right, need a negative, it's flipped. I'm going to move it for the point to 4, right, up 1. So how do I say right 4? Negative 4. How do I say up 1? Outside. Up 1, what I think. All right, is that where it is? Yes, it is. Now it looks thinner than this, so I need to figure out my slope. Because remember, absolute value is just 2 lines, right? So this is a line and this is a line. So it's 1, 2, 3, 4, 1. So this is 1, 1. So I need it to be 4, 1, which simplifies to 4. And we're just going to double check. So I'm zooming in a little bit. Let's check a random point. Let's check. Do we have 2, negative 7? So 2, negative 7. So it's this side. That's 4. Hold on, sorry. Zoom out a little bit. 1, 2, 1, 2, 3, 4, 5, 6, 7. Yes, we do. Right here. All right, so this is correct. Now you're just going to come in and type it in. All right, so we're just using the calculator to just double check our answers because I definitely don't feel like getting it wrong. I'll be here all day. Y'all know y'all hate getting it wrong. All right, another absolute value. It's flipped, so I'm just going to keep the flip there because we already know that's what it is. So boom, negative x. All right, then I need to make it look like this. So far, I just need to move it left 2, right? How do I say left 2? Opposite of what you think. So plus 2. All right, that's where it is. So I got the point at 2, 0. Let me check my slope. Is it 1, 2, 3? Is that a point? No. I think this is the point right here. So it's going down 7, 1, 2, 3, 4, 5. Going down 7 over 5. Going down 7 over 5. And we're just going to double check one of these points. So let's pick a corner. That's not a corner. This is a corner right here. So that's at 3, 7. So 3, negative 7, sorry. Wait, that's not right. This one comes over 3. So maybe I counted wrong. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So I should go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Yeah, so I should have 3, negative 7. What did I do before? So do I have 3, negative 7? I do. I don't know what I was counting before. All right, so just double check it with a calculator. Put the fraction in, and then 7 over 5 is my slope. This is x plus 2. Oh, and we're done. Okay, so again, rewatch the video if you need to. This one, you do need to know the rules. Unlike the other one, you could kind of check. So definitely rewatch the video if you need to.